Hello everyone, in this video we're going to focus on top 7 integrals and applications FRQs that most tested on the AP Calculus BC exam. Also, if you want to review the concept behind this topic, please check out the link in the description below. Now let's move on to question 23. There is no snow on Janet's driveway when snow begins to fall at midnight. From midnight to 9 a.m., snow accumulates on the driveway at a rate modeled by FT equals 70 e to the cosine t cubic feet per hour, where t is measured in hours since midnight. Janet starts removing snow at 6 a.m., which means t equals 6, so 9 a.m. t equals 9, right? And midnight t equals 0, right? The rate t of t in cubic feet per hour at which Janet removes snow from the driveway at the time t hours after midnight is modeled by this piecewise function. Question C. Let h of t represent the total amount of snow in cubic feet that Janet has removed from the driveway at time t hours after midnight. Express h as a piecewise defined function with domain from 0 to 9. From 0 less than t less than equal to 6, then we have h of t equals the initial amount h of 0 plus the interval from 0 to t of g of s ds, right? And h of 0 equals 0 plus the interval from 0 to t, right? Within this interval, the value is 0, right? So it could be 0 ds, and the answer must be 0. Now, the second interval is could be from 6 to 7, right? So, h of t equals h of 6 plus the interval from 6 to t g of s ds, right? 0 plus the interval from 6 to t of 125 ds, right? So it's going to be 125 s evaluated from 6 to t, right? So it could be 125 times t minus 6. The third interval is going to be from 7 less than t less than equal to 9. Then you have h of t equals h of 7 plus the interval from 7 to t g of s ds, right? H of 7 is going to be 125 right here, right? Plus the interval from 7 to t of 108 ds, and it's going to be 125 plus 108 s evaluated from 7 to t. It's going to be 125 plus 108 times t minus 7, right? So the piecewise function is h of t equals. Now question D. How many cubic feet of snow are on the driveway at 9 a.m., which means t equals 9, right? So you need to calculate the interval from 0 to 9, right? Of rate in subtract rate out, right? So it could be f of t dt subtract h of 9, right? So it's going to be the interval from 0 to 9. Of this guy right here, 7 t e to the cosine t dt subtract h of 9 is going to be this expression right here, right? Press Ctrl Enter. It's going to be 26.334. Now let's move on to question 24. Let g be the function given by g of s equal 1 over square root of s. The average value of a function f on the unbounded interval a to infinity is defined by this guy. Show that the improper interval from 4 to infinity g of s ds is divergent, but the average value of g on the interval 4 to infinity is finite. We have the interval from 4 to infinity of g of s ds equals limit when b approaches infinity of the interval from 4 to b of g of s ds, but g of s equals this one. So it's going to be limit when b approaches infinity of the interval from 4 to b of s power of negative 1/2 ds, right? So it's going to be limit when b approaches infinity of 2 square root of s evaluated from 4 to b, right? And it's going to be limit when b approaches infinity of 2 square root of b subtract 2 square root of 4. It's going to be 4, right? Approaches infinity, right? Infinity subtract 4 is going to be infinity. The interval from 4 to infinity of g of s ds is divergence. Now we need to calculate this one, right? So we have limit when b approaches infinity of the interval from a to b of f of s ds over b minus a is limit when b approaches infinity of a right here equals 4, right? So it could be 1 over b minus 4 of the interval from 4 to b of 1 over square root of s ds, right? But this guy right here has been calculated right here, right? So it could be limit when b approaches infinity of 2 square root of b minus 4 over b minus 4, right? Alright, so when b approaches infinity, this guy right here grows faster than this guy. This guy right here grows faster than this guy, right? So it's gonna be limit when b approaches infinity of 2 square root of b over b, right? Now we're gonna simplify this one, so it's gonna be limit when b approaches infinity of 2 over square root of b, right? When b approaches infinity, this guy approaches 0, right? So this one is finite. Now let's move on to question 25. The derivative of a function f is given by this guy for s greater than 0. If f of 1 equals 7, then we need to find the value of f of 3, right? So we're going to use the fundamental theorem of calculus, right? So we have f of 3 equals f of 1 plus the interval from 1 to 3 of s minus 3 e to the s, right? Now we're going to calculate this one on the side, right? So the interval from 1 to 3 of s minus 3 e to the s ds. We need to use integration by part, right? So we let u equals s minus 3, du equals ds, dv equals e to the s ds, v equals e to the s, right? So this guy becomes u times v, which means this guy times this guy, right? S minus 3 times e to the s evaluated from 1 to 3 minus v du, which means this guy times this guy, interval from 1 to 3 of e to the s ds, right? It's gonna be s minus 3 e to the s subtract the entire derivative of this one, it could be e to the s, right? All together evaluated from 1 to 3, right? So I substitute 3 for s, it could be, the first one is 0, right? The second one is negative e cubed, right? Substitute 1 for s, I get subtract negative 2e, subtract e. So it's going to be negative e cubed. This guy turns out to be negative 3e, and negative right here is positive 3e, right? So finally, f of 3 right here equals f of 1 equals 7 plus this guy right here 3e minus e cubed, right? This one is the final answer. Now let's move on to question 26. If dy over ds equals this guy, y equals 3, s equals 5, what is the value of s equals 5.5? Again, we're going to use fundamental theorem of calculus, right? So we have y of 5.5 equals y of 5 plus the integral from 5 to 5.5 of this guy, right? Now I'm going to calculate this one on the side. Now I'm going to factor negative side out so that I'm going to do complete square, right? So this guy turns out to be the integral from 5 to 5.5 ds over. In order to find the missing term right here, I'm going to take the middle term right here, 10 divided by 2 and square, right? So it could be 5 square, right? So I just literally subtract 25, right? I need to add 25. Subtract 24, right? So it's going to be 1 minus s minus 5 altogether square, right? Now I want to apply the formula antiderivative of du over square root of a square minus u square. It's going to be a sine of u over a plus c, right? Now u in this situation is s minus 5, right? A in this situation is 1, right? So the top, look at this one right here. This is u, this must be u, right? So this guy must be s minus 5, right? Derivative of ds minus 5 is going to be ds, right? So they're both the same. So now I can apply the formula right here. So it's going to be a sine of s minus 5 over 1, right? Because a equals 1. Evaluated from 5 to 5.5, right? Substitute 5.5 for s, so it could be a sine of 1/2, right? Substitute 5 for s, it could be a sine of 0, right? A sine of 1/2 is going to be pi over 6. A sine of 0 is going to be 0. So we have y of 5.5 equals y of 5 is going to be 3 right here. Plus pi over 6, right? Now let's move on to question 27. The graph of a differentiable function f is shown for negative 3 less than equal to s less than equal to 3. The errors of the region A, B, C, D are 5, 4, 5, 3 respectively. Question D. Let h be the function defined by h of s equals this guy. Find the value of the integral from negative 2 to 1 of h of s ds. Alright, so basically this guy is the same thing as the integral from negative 2 to 1 of 3f of 2s plus 1 plus 4 ds, right? So it's going to be 3 times the integral from negative 2 to 1 of f of 2s plus 1, right? ds plus 4 the integral from negative 2 to 1 of ds, right? Now I need to calculate this one first, right? So I'm going to let u equals 2s plus 1 and du equals 2 ds, right? So ds equals 1/2 du, right? Now I need to change the new upper bound and lower bound, right? So the O1s equals negative 2, s equals 1. Then the new one, u equals, substituting negative 2 for s is going to be negative 3, right? Substitute 1 for s is going to be 3, right? So this guy becomes the integral from negative 3 to 3 of f of u du. Now I have 1/2 here, I put 1/2 in the front, right? So now I can use this graph to find the error under the curve, right? Remember this guy must be the same, right? In order to use this graph, right? So it's going to be 1/2. The first one right here, A, is going to be 5, right? The second one, B right here, is below that axis, it's going to be -4. The third one, C right here, is going to be 5. And the last one right here, D, is going to be 3. So, the answer is 9/2. I substitute 9/2 over here, so it could be 3 times 9/2, right? Plus 4s evaluated from -2 to 1, right? So it could be 27/2 plus 4 times 1 plus 2, right? So the final answer should be 51/2. Sarah rode a stationary bicycle. The number of rotations per minute of the wheel of the stationary bicycle at time t minutes during Sarah ride is modeled by function s, defined by s of t equals this guy for t between 0 and 9 minutes. Find the average number of rotations per minute of the wheel of the stationary bicycle for t between 0 and 9 minutes. Alright, so we're going to use the average formula, right? So we have 1/b minus a. This is a, this is b, so it will be 9, right? Integral from 0 to 9 of s of t dt, right? So it will be 1/9. Integral from 0 to 9 of 40 plus 20 pi sine of pi t over 18 dt, right? So it's going to be 1/9 times 40 t, right? Now remember, antiderivative of sine of as plus b ds is going to be -1/a cosine of as plus b plus c. So keep this one in mind, right? So a in this situation is pi over 18. Now you just flip this one, it's going to be 18 over pi, right? It turns out to be -360 cosine of pi t over 18, right? Evaluated from 0 to 9, right? So I'm going to substitute 9 for t, so it could be 1/9 times 360 subtract 9 for t over here, it's going to be cosine of pi over 2 is going to be 0, so we don't have to worry about this guy anymore, right? Substitute 0 for t, this guy equals 0, right? This guy becomes -360, and subtract -360 is going to be +360, right? So it could be 720/9, and it's going to be 80 rotation per minute. Now let's move on to question 29. Consider the function f given by this guy. Evaluate the integral from 0 to infinity of Ls ds. The integral from 0 to infinity of s times e to the -2s. Limit. When b approaches infinity of the integral from 0 to b as e to the -2s, right? So we're going to use integration by part, right? Let u be as du equals ds, dv equals e to the -2s ds, v equals -1/2 e to the -2s. Integral from 0 to b of s e to the -2s ds becomes u times v. This guy times this guy, right? It's going to be -1/2 s e to the -2s evaluated from 0 to b minus v du is going to be right here. So plus 1/2 integral from 0 to b of e to the -2s ds, right? So this guy becomes -1/2. Substitute b for s, so it could be b times e to the -2b. Substitute 0 for s, could be 0, right? Plus, now antiderivative of e to the -2s, it could be -1/2, right? So it could be -1/4 e to the negative 2s evaluated from 0 to b, right? So it's going to be negative 1 over 2b e to the negative 2b minus 1 over 4 times e to the negative 2b. E to the 0 is going to be 1, right? Now I'm going to simplify this one, so it's going to be negative b over 2 times e to the 2b, right? Distribute this one, so it's going to be minus 1 over 4 e to the 2b, right? Plus 1 over 4, right? Now I'm going to factor negative 1 over e to the 2b out. So it's going to be b over 2, right? Plus 1 over 4, right? Plus 1 over 4 right here, right? Now I'm going to bring this guy back over here. So I have limit when b approaches infinity of, now when b approaches infinity, this guy approaches 0, right? 0 times this guy is going to be 0. The answer is 1 over 4, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.